Dr. Orley, so nice of you to join us today.
My pleasure.
You've been, with CSAIL and in the space for a long time. Since 1996, you've been working on evolutionary algorithms, and you've been, applying adversarial artificial intelligence to cybersecurity, to climate change, to software space in general. And now we're seeing this, explosion in the use of large language models and generative AI. Could you comment on your journey in the space and what you are most excited about going forward?
Well, I think everyone in the LLM space has an aha moment, right? You hear about the technology, other people are using it, and you think it doesn't really apply to anything I do. And actually, in my research group, we had that aha moment. We were actually just looking at how people were using language models for robots. Right? And robots are physical beings, and they can sense the world, they can observe it with their sensors, and they can choose and decide what they need to do depending on their goals and take actions. And we were looking at how LLMs were being used to really make robots more intelligent and more easy to command and task. And when I thought about it, what I realized was that in cyberspace, we have the same environment as robots have in the physical environment. And our environment is just like computer networks and computer operating systems and all the services that run on computers. And I realized that our agents that we wanted to build that would, test these networks for security and even help the network be more secure, they could be helped by LLMs because they needed to sense the environment. They needed to understand what they were sensing and then take actions in the environment, just like the robots were. So we took a lot of inspiration from LLMs and robotics, and we transplanted that to thinking about cyber agents that are really quite realistically manipulating the commands in computer networks.
That's so interesting. And since you've spoken about manipulating commands, and we're talking about robotics, there's often a concern about the problems we see with LLMs, and quite a lot of that has to deal with misinformation, producing information just wrong, hallucinations. You've worked with that a little bit in climate change as well. Could you talk about that?
Well, I look at it from two different perspectives. One is that when we use the LLM, we have to write bulletproof code or take different approaches that mean that we don't critically depend on the LLM for some piece of extremely accurate information. So we definitely design around the fact that LLMs hallucinate, but we do stay awake at night worrying about LLMs, not because they hallucinate, but just because how good they are at generating language and arguments that could be used to generate misinformation and disinformation. And if you're like me, who sort of is enthralled with adversarial behavior, one of the biggest impediments to us understanding climate change and taking action is disinformation and misinformation around climate change. So I'm quite alarmed at the possibility that someone could use these language models in a negative sense to propagate more of that misinformation and disinformation around climate change.
Right. And you've also, done a lot of work on artificial adversarial intelligence. And this is a technology that has been used in a very positive way with generative adversarial networks, where you have the generator and discriminator working against each other. What do you see as applications of this in the LLM space? Do you see this making a significant impact as we go ahead?
That's a really good question. Right now, we've been thinking about GANs, generative adversarial networks, and thinking about how they could cooperate. And, in both of those cases, whether you cooperate or you have adversarial networks, we tend to use very traditional deep networks, not transformers that are very, very large, that can be trained in parallel and that rely on a huge amount of training data. I think where the LLMs really come into play with artificial adversarial intelligence is this ability to, create co-pilots or agents with them. And those can actually help with the defensive workflow that we need to, anticipate various kinds of threats that we see and, be ready with countermeasures for them.
Right. And of course, cybersecurity is a very important, metric here. even safety with LLMs, companies developing LLMs. We hear news about OpenAI's safety teams and concerns around that. What measures do you think the leaders in the space can take to ensure that we build AI technology that is safe for us going forward?
Yes. Well, I make a big distinction between safety and security. Some would think that I'm more interested in security. Security is about what can happen to a model so that it starts to operate unsafely. And safety is about what happens to you if the model does something wrong. And I think that as the models get more and more competent, which we've seen happen, though it's not clear to me if that rapid improvement in competence is going to continue. I mean, that the question's out on that. But if these models become more and more competent, I guess the concern is that they could take on almost autonomously a adversarial relationship on their own without even humans, and that they might be making decisions too quickly without human oversight is really concerning. And so I think I've been very impressed by Anthropic's constitution. I've been very impressed with Anthropic's work where they have been trying to mechanistically interpret what happens inside a language model. And I think they've made some breakthroughs even in the last week or two that they've released to archive. And it's really is concerning that companies may put commercial benefit over prioritize that more than safety. And the example that really worries me is social media platforms. I think that we're all really realizing now how harmful they have been to certain segments of our society. I think particularly in the US, young girls are very, very vulnerable to the social pressures that come from social media platforms. And unfortunately, we raced ahead to build these social media platforms. And post hoc, we thought about, well, could they cause any harm? And I think that's the example that we have to bear in mind. We don't want the horse to go out of the barn and try and close the door after it's left. And I think that it's not an easy question, but at first I was very impressed with OpenAI devoting so many resources to safety. It's a little disheartening to learn that they may not be doing that anymore.
And you spoke about the Constitution, you spoke about groups of models collaborating. As you see advancements in the space, everyone's excited. A lot of people are excited about AGI or artificial general intelligence. Do you think the roadmap to that, we're going to see the transformer architecture being predominant, or do you see potentially alternative architectures, taking the lead eventually in the race to that?
Well, I don't have a crystal ball, and I'm probably not that much more informed than most people. But something tells me that the transformers are not the full route. I think that we learned something about scaling, and it was afforded by this opportunity and this confluence of lots of computation with lots of data, and some daring thoughts and ideas. And it got us to this new, maybe perhaps a new rise, but also a plateau. And I think it's pretty clear that you and I don't learn with that many training examples, and that you and I aren't born and develop our intelligence in the same way as what we're trying to do right now with our architectures and with our training mechanisms. So I suspect that artificial general intelligence is a little bit longer off than most people think. Does that mean that on the road to that, we shouldn't be actually very careful about the kinds of competency we get from the models? No. But I'm kind of on the skeptic side for believing that our current path is putting us in sight of AGI. I think we are going to have to see some more disruptive ideas and technologies arrive before we have it.
Super interesting. And in terms of the technologies we have today, we just saw GPT-4o, and we've been seeing Sora. What's the most exciting applications of LLMs that you are seeing today and that you believe has a lot of promise for the future?
That's a great question. I mean, why don't we work on the hardest problems we have? I think, and the most important ones. And I think one of the hardest and most important problems we have right now is climate change. So the unfortunate part is that so much of climate change technology is already there. What's missing is our will. So how do we use these enhance models to effect action on climate change, I think is a really open question, but one that I think people should pursue. And I think there's open questions in science, there's open questions in engineering. It's very fascinating to see how these models can sort of interact with some very fundamental science questions and make advances on them. So I'm very hopeful about those directions.
That's awesome. Well, thank you so much, Dr. Early, for this conversation. Really appreciate it.
Oh, it was my pleasure.